Welcome to my channel. In this video, I will discuss Milne Thomson method. This is regarding the construction of an analytic function whose real part or imaginary part is given to us. So let us go to the method. So what are the informations given to us? A complex function fz whose real or imaginary part is given. So fz is a complex function, so it has a real part, say u, and an imaginary part, say v. Now, next information is fz is an analytic function. And either u is given to us or v is given. So let us consider the first case, that is if u is given. So case 1, if the real part u is given. So our function fz is u plus iv. So if we differentiate fz with respect to x, we get f dash of z, that is equal to ux plus ivx. Now u is given to us, so we can calculate ux. Now what about this vx? So for this we need to take the help of the second information, that is fz is analytic. Now if fz is analytic, then its real and imaginary part satisfies Cauchy-Riemann equation, that is ux equal to vy and uy equal to minus of vx. So from here we are getting f dash of z equal to ux, and vx is minus of iuy, so it is iuy. So now we have the expression of f dash of z in terms of our known functions, because u is known to us. Now in the Milne Thomson method, the second step is let ux be phi 1 xy and uy be phi 2 xy. Next we'll put x equal to z and y equal to 0. So if we put x equal to z and y equal to 0, we get f dash of z as phi 1 at z0 minus of I phi 2 of z0. If we integrate, here we get integration phi 1 of z0 minus I phi 2 z0 dz plus c, where c is a constant, and this is our required analytic function fz. Next, let us go to the next case, case 2. That is, if v is given, that means the imaginary part is given. So in that case, we have f dash of z equal to, if we differentiate with respect to x, we are getting ux plus ivx. Now here v is known to us, so vx is known, so we have to replace ux, and the function fz is analytic. So u and v satisfies Cauchy-Riemann equation, that is CR equations. which is given by ux equal to vy and uy equal to minus of vx. So here we'll replace ux by vy and we'll get f dash of z equal to vy plus ivx, because here u is not known to us. Here we have v, so we can calculate vx and vy to get f dash of z. So now, like the previous case, here we'll assume vy to be phi1 xy and vx to be phi2 xy. Then we'll replace x by z and y by 0, so that we get vy as a function of z0. So our f dash of z becomes phi1 of z0 plus I phi2 of z0. Now if we integrate, we'll get fz, our required fz, that is phi1 of z0 plus I times phi2 of z0 dz plus a constant c. Let us take this example. So here we need to determine the analytic function fz whose real part is u and imaginary part is v, and v is given to us. So let us first differentiate v with respect to x. So if we differentiate with respect to x, we get vx equal to 4x cube minus of 12xy square, and if we differentiate v with respect to y, we get minus of 12 x square y plus 4y cube. Now the function fz is u plus iv. So the first step is to differentiate fz with respect to x or with respect to y. So let us differentiate fz with respect to x. Differentiating f with respect to x, we get f dash of z equal to ux plus ivx. Now this vx is known to us because v is given, but ux is not known. Now the function fz is analytic. So since the function fz is analytic, so we have Cauchy-Riemann equations. So ux equal to vy and uy equal to minus of vx. So from here we can see ux is equal to vy. So here we can replace ux by vy, which is known to us. Now in the next step in the Milne Thomson method, that is, let vy equal to phi1 xy and vx equal to phi2 xy. So what is our phi1 xy here? That is equal to vy, that is minus of 12x square y plus 4y cube, and phi2 xy is equal to vx, that is 4x cube minus of 12xy square. Next, we need to put x equal to z and y equal to 0. So for this values of x and y, we are getting phi1 z0 is equal to minus of 12z square into y, that is 0, and 4 into 0 cube, that is 0, and phi2 z0, that is equal to 4z cube. So from here we are getting f dash of z equal to vy, that is phi1 z0 plus I times phi2 z0. So here our f dash of z equal to phi1 z0 is 0 plus I times phi 2 z0 is 4z cube. So if we integrate, we get fz equal to 4I integration of z cube dz. So it is 4I into z power 4 by 4 plus c. So we are getting I z power 4 plus c, which is our required analytic function. Our next example is find the analytic function fz whose real part is given to us. So here if we apply Milne Thomson method, so first we have to differentiate u with respect to x. So what is ux? So it is e power x into cos y, and ui equal to minus of e power x sin y. So fz equal to u plus iv. Now if we differentiate fz with respect to x, we'll get f dash of z, that is equal to ux plus ivx. Now in this case, ux is known because the real part is known, but vx is not known. So here fz is analytic. So we are getting ux equal to vy and ui equal to minus of vx. So here we can see vx equal to minus of ui. So we'll replace vx by minus of ui, which is known to us. So here we are getting f dash of z equal to ux minus of iui. Now let us take ux equal to phi 1 xy, which is equal to e power x cos y, and ui equal to phi 2 xy. So here it is minus of e power x sin y. Now if we put x equal to z and y equal to 0, we get phi 1 z0 equal to e power z into cos 0 is 1, and phi 2 z0 is equal to minus of e power z into 0. So it is 0. So here we are getting f dash of z equal to phi 1 z0 minus I times phi 2 z0. Now phi 1 z0 is e power z and minus of I times 0. So our f dash of z equal to e power z. Now if we integrating star, we are getting fz equal to e power z dz plus c, where c is integration constant, that is equal to e power z plus c, which is our required analytic function. C is an arbitrary constant. Thanks for watching. If you enjoyed the video, then please like and subscribe my channel.